Here is the completed Arm Mark 6. It is a robot arm with 4 degrees of freedom. It has several joints powered by different motors. At the base, there is a stepper motor inside this box connected to a planetary gearbox, or compound planetary gearbox, with a total reduction of 25 to 1 to give enough torque to adequately move it without anything falling over. And all the rest of the joints are all servo motors for simplicity. All the servo motors have an additional wire soldered inside of them that connects to the internal potentiometer for measuring position. This is used for the initialization sequence of the arm. The enclosure where all the electronics sit has a fan for cooling, since the stepper driver does get quite warm. It is controlled through this front panel, consisting of a switch and several buttons. The buttons control the motion of each joint, while the switch is the power switch. The whole thing is powered by this cord here. And to adequately demonstrate the initialization, I can move it to some random position like this, lift the cover, turn it on, and as you can see, the whole thing initializes. All the joints move to their correct position, and the stepper motor initializes. And I can move it up and down with these buttons. Now let me just get another demonstration of the initialization, because it didn't quite initialize correctly there. There are still a few bugs in the software. The servo joints are all supposed to initialize one after another. This one, then this one, then this one. And then the stepper motor should initialize. But it didn't do that, it did it all at once. So let me try that again. Yeah, that's more like that's the behavior that I expect from it. The stepper motor moving a little bit on startup while everything goes is expected. I don't know what causes it, but it doesn't affect operation. So now I can move it around and manipulate it however I want. Oop, got a little stuck there. There's still a few hardware details that could be sorted out, such as the hand being able to hit this tiny bolt here and get it caught on itself, but it doesn't happen too much, and I've worked on this project long enough, and it's a simple enough issue that I don't feel it's worth taking my time to deal with it. This is more so just so I can better understand how to construct something like this, and I learned a lot from it. So I'm not too concerned about it. The hand could open and close. Let me see if I can just get a good view of how the hand operates. It has the servo motor with some 3D printed gears here. Now there is quite a bit of backlash in the hand, but again, you know, it's not meant to be perfect. It's not meant to be perfect, so I'm not too concerned with it. Everything is held together by various bolts. Some of the bolts aren't. They don't have a bolt on the other side. Or they don't have a nut on the other side. Forgive me. They don't have a nut on the other side, and that is because, due to some printing issues, the hole is just small enough that the bolt threads directly into the plastic. So it's still secure. And the hand, and the components here are modular. They're easily removable and can be replaced with other things. I haven't designed any other end effectors for it, but in theory it would be quite easy to replace them. I can demonstrate that in just a moment. Alright, I have the robot turned off, and I will now just show a few details of it while it's not running, such as the how this part is assembled, how the hand is connected to the elbow. So bolt just screws right out, and probably should have held it, but here's the hand. It has a hole there. Now the bolt is in a threaded insert, and there is a square cavity where the bolt goes out through and goes through this hole here to lock it in place. And I can show you the electronics enclosure. Be warned, it isn't very good, but it functions. This part just pops right out, and you can already see the mess. You just go like that, and there it is. We have an Arduino Mega microcontroller, and that's the brains for the whole operation. I would pull it out and show it, but I don't want to mess up anything. There is a perf board in there with some components soldered onto it, such as the stepper driver and the servo driver. But again, if I pull it out, I could risk messing something up in there, because this is not a very good electrical enclosure. I do not like it. I do not like it at all, but it functions, and my future projects will be a lot more refined than this. It's a pain to put this cover back on too. But yes, there's a fan for cooling, and on the other side, because the cooling was an afterthought, there are some holes punched into the print for airflow, and that seems to do the trick. I haven't had any issues with it. Yeah, it's done. Bunch of cables, and some future things of note for future projects. These are all these wires are made for breadboard prototyping. They all have headers on them, male, female, whatnot. In the future, I would like to use actual spools of stranded core wire, so I can make them of my own length and then attach headers onto them, because it works, but it has its flaws using these pre-cut ones. Enclosure design is something I need to work on, and where everything sits. I think printing this main enclosure as one big part with just an opening here and an opening here, where this front panel bolts on, wasn't a very good idea. I think this whole top part should open for better access to the electronics. I think I should actually plan out where the boards will go and where the wires will go, and I plan on doing that for my future project, for my summer project I will be working on. Yeah, that is the Robot Arm Mark 6.5 is the full name of this project, and I think it turned out, regardless of the flaws, I think it turned out really well. This here is the actuator inside the planetary gear gearbox attached to the stepper motor. It is a 25-to-1 reduction. Every 25 turns of the stepper motor is 1 turn of the output shaft. It has 2 sets of gears, with the output carrier of the first set being attached directly to the sun gear of the second gauge, and the whole thing is held together with bolts and bolted to the base, and it all works out pretty well. One thing, if I had to change some things in the future, would be to use regular spur gears as opposed to helical gears, as I don't fully require the benefits provided by the helical gears, and as I'm not using the benefits, it makes the one downside a little bit more of a downside, which is in depending on the direction, there's a linear force applied with the gears, or they push in a certain direction. They push up or down towards or away from the motor, which in turning in one direction, there is a noticeably higher amount of rattling in the gearbox, which isn't too much of an issue. It's just if I were to use spur gears, it would be uniform, which is, in my opinion, better. And the whole thing is filled with lubricant, with grease, to help with that, because it sounds like a blender without any grease in it. So it turns pretty smoothly for the most part. Still a lot of rattling, but that's all just backlash and the prints and stuff like that. So I'm fine with how it turned out. I got to design a gearbox. It works. Who could ask for more, you know?